Christmas! This is our last chem tutorial for this year, 2014. In this video, we're going to be talking about naming compounds. And so sometimes this can get a little bit confusing when we're trying to name compounds because compounds will either fall into one of two categories. If you're looking at a compound and you're trying to figure out how to name it, the first thing you have to ask yourself is the compound ionic or is the compound covalent? Because if the compound's ionic, we're going to use a set of rules to name that compound, whereas if the compound was covalent, we use a different set of rules. And then once you know that, then you can follow the specific set of rules to name it. So go ahead and write these rules down on your notes in that big blank white spot. Okay, there are three types of ionic compounds we're going to learn how to name. The first is a binary ionic compound, which just means something that has a metal and a nonmetal. These are going to be the two example problems we're going to work through. So go ahead and write these on your paper. So when we're trying to name BAF2, we have to ask ourselves, is it ionic or is the compound covalent? The way we know that is ionic compounds have a metal and nonmetal. If I look at barium on the periodic table, it is on the metals side on the periodic table. It's on the left side. Fluorine is a nonmetal. So I know I'm going to be following the ionic naming rules, not the covalent naming rules. So I'm not looking at those right now. I'm going to ask myself, is this first element, see how there are two elements. There's Ba and then there's F. So right now I'm just looking at my first element. Is it a metal, is it a polyatomic, or is it a transition metal? When I look at Ba, it's in group 2, which means it's just a regular metal. It's not a polyatomic and it's not a transition. Since it's a regular metal, the rule is to just name it. So I'm going to name it. Okay, now we've done the first element. Now let's look at the second element, fluorine. In the second element, we have to ask ourselves, is it a polyatomic or is it a regular nonmetal? Fluorine is a regular nonmetal because it's on the periodic table. If it's not on the periodic table, then it's a polyatomic. So since it's a nonmetal, we're going to name the element, but we're going to add a new ending. And the ending is going to have IDE to the ending. Okay, so we're going to name it fluor, and instead of doing fluorine, I'm changing it to fluoride. Okay, so I have my new ending, fluoride. Barium fluoride is the name for this binary ionic compound. Okay, so here's our next example, Ca3N2. Again, the first question we have to ask ourselves is this compound ionic or covalent? Calcium is a metal, nitrogen is a nonmetal. So I know it's ionic, so I'm not going to look at my covalent rules, only my ionic rules. Now let's look at the very first element. That's calcium. Is it a metal? Is it a polyatomic? Or is it a transition metal? Calcium is in group 2, so it's a regular metal, which means I just name it calcium. Now let's look at the second element. The second element is nitrogen. Is nitrogen a polyatomic or is it a regular nonmetal? It's a regular nonmetal because it's on the periodic table. So I'm going to name it and I'm going to add my IDE ending. So instead of writing nitrogen, I'm going to write nitride. Okay, again, I'm adding my IDE ending, so nitride. Notice that nitride is very similar to two polyatomic names. One polyatomic is named nitrate and one polyatomic is named nitrite. If there's a T at the ending, you know it's going to be a polyatomic. If it's an IDE ending, you know that it's just a regular nonmetal that we just used from the periodic table. Okay, so the D stands for just a regular nonmetal. The T on the endings is going to stand for a polyatomic. What are you staring at? It's just a hat, people. Come on. Ion. Okay. All right, so let's do another example. Everything I've shown you so far has just been a binary ionic, which is a regular metal and a regular nonmetal. Now let's move on to a more complicated one. Now we're going to do problems where we have transition metals. Okay, so the first problem we're going to do is CuCl. CuCl, what type of compound is it? Ionic or covalent? Well, copper is a metal. It's actually a transition metal because it's in groups 3 through 12. Copper is a nonmetal. So again, I know it's ionic because there's a metal and a nonmetal. It's not covalent, so I'm not even going to look at these covalent rules. Okay, so look at the very first element. Is it a regular metal? Is it a polyatomic? Or is it a transition metal? Copper happens to be in group 11, which means it's in that block. Remember, if this is a periodic table right here, anything in here is a transition metal. So since it's a transition metal, I'm not going to do the metal rule. I'm not going to do the polyatomic rule. I'm going to do the transition metal rule. What's the rule for transition metals? The rule for transition metals is you name it just like regular. So I write copper. But then I have to add something after copper using parentheses and Roman numerals. I have to write down the charge of copper as a Roman numeral in parentheses. I'm going to say that again. For a transition metal, you have to write the charge as a Roman numeral in parentheses. Why? Well, copper, we know it's in group 11. We don't know how many valence electrons copper has, and that's because it's not in one of our normal groups, right? It's not in group like 1, 2, 13, 14. So we don't know how many valence electrons, so we don't know its charge. Copper's charge changes. Really, any transition metal has a charge that will change. Usually, there'll be +1, +2, or +3 charges, usually. And that may be something you want to write down. Usually transition metals have a charge of +1, +2, or +3. How do we know what copper's charge is in this compound? Because copper's charge will change depending on what it's bonding with. The way I know is by looking at my formula, CuCl. So I don't know the charge of copper, but I do know that it's an ionic compound. That means its overall charge is neutral. I also know the charge of chlorine. Chlorine's in group 17, so its charge is -1. What charge would copper need in order to get a neutral compound? Copper would need a charge of +1. So I'm going to take copper's charge and I'm going to write it into this parentheses using Roman numerals. I just write a big 1. That 1 stands for +1. Since it's coming right after the copper, this number 1 is actually referring to the charge of copper. Okay, so now I've done that part. I've done the first one. What about the second element? The second element, is it a polyatomic or is it a regular nonmetal? Chlorine is a regular nonmetal, so I name it and I add my ending "ide." So I write, instead of writing chlorine, I'm going to write chloride. So copper 1 chloride is the name for CuCl. Okay, so here's our second transition metal problem. I have to ask myself, is this ionic or is this covalent? Zn is a transition metal, Br is a nonmetal. So I know it's ionic, so I'm not going to worry about my covalent rules. Okay, so I look at my very first element here, that's Zn. It's not a regular metal, it's not a polyatomic, it's a transition metal. So what's my rule for transition metals? I write the name, so I write out zinc, and I have to write the charge as a Roman numeral. So here's my parentheses. I have to put the charge right here. How do I know the charge of zinc? Well, I have to write out my formula, Zn, and I don't know the charge of Zn, but I do know the charge of bromine. Bromine's charge, since it's in group 17, is -1. However, how many bromines do I really have? I have 2 of them. So I'm going to put a 2 right outside the parentheses. So really, bromine's total charge is -2 because I have 2 bromines and they each have a -1 charge. So when I multiply 2 times -1, it gives me -2. So what charge would zinc need to have in order to give me a neutral compound? Zinc's charge would then have to be +2, so that +2 - 2 would get me a neutral compound. So zinc's charge is going to be Roman numeral 2, +2. Now, how do I finish it? Well, I have to look at I did my first element. What's my second element? It's not a polyatomic. Bromine is a regular nonmetal. So I name it and I add the IDE ending. So I'm going to write, instead of bromine, I'm going to write bromide and add my ending. So zinc 2 bromide is the name for ZnBr2. Okay, so we've done regular ionic compounds, we've done ionic compounds with transition metals, and now I'm going to teach you how to write ionic compounds with polyatomic ions. Okay, so again, I have to ask myself, is this an ionic compound or covalent compound? Well, magnesium is a metal, right, because it's on the metal side. Nitrogen is a nonmetal, and oxygen is a nonmetal. So this is ionic. And why is it ionic? Because there is a metal and it's with nonmetals, so it's ionic. If this didn't have the metal, if it was just nitrogen and oxygen, then it would be covalent. But since magnesium, the metal, is present, it is an ionic compound. So we are going to pretend, anytime you see a polyatomic, by the way, That's something that's in parentheses, okay? Or sometimes there's not parentheses around it if you only have one polyatomic, but you should at this point in time start to recognize what your polyatomics are. So anytime you see a polyatomic, we're going to treat it as the second element, okay? The first element is magnesium. Is it a metal, a polyatomic, or a transition metal? Magnesium is in group 2, so it is just a regular metal. So all I have to do is name it. So I write magnesium. Okay, my second element. Is it a polyatomic or is it a nonmetal? NO3 is a polyatomic. So I have to look on my chart and name it from the chart. So I look up on my chart, what is NO3? NO3 on the chart is nitrate. So all I have to do is write magnesium nitrate. Did I have to change the ending at all? No. All you got to do is pull up this sheet and you'll see that nitrate is written on here and I just write it out. All I have to do is find the name on here that matches the symbol NO3 and I just write out the name. So magnesium nitrate is the name of this compound. Now this whole time we've been talking about compounds that are ionic. I'm now going to give you guys a bunch of compounds that we're going to go through where we follow the covalent rules. So over here on the left on your side of the page, I wrote down the prefixes that we talked about in one of our previous videos. So just fill this in at this time right now. Just fill this in. And we're going to be talking about how to name covalent. So our very first example is sulfur and oxygen. And I know that I'm going to be following the covalent rules for this molecule because sulfur is a nonmetal and oxygen is a nonmetal. So since both of them are nonmetals, I look back at these rules and I say, okay, since this is a covalent compound, I'm not going to be doing anything with my ionic rules. I just look at my covalent rules. So we are going to do SO. The first element is sulfur. And if what we have to do when we're writing covalent compounds is we look at the number next to the formula. So right here I don't see a number next to the S, and so that means it indicates that we just have one S. If we have one atom of the first element, we just name it and we don't do anything fancy. So we'll name this sulfur. I'm not adding anything to it. That's our first. Our second element is oxygen, and you always have to use a prefix on your second element. And so let's look at the prefixes. We know that the prefix for 1 is mono because we look right over here and I see mono means 1. So before, a prefix is something you put before anything else. It's like your bay. So you write sulfur and then we're going to write mono because that's going to stand for 1 oxygen, and then I just write oxygen, and instead of writing oxygen I have to change my ending to IDE. So I have a prefix and then I have my element and then I have the ending IDE. So I wrote down the little formula down here. Prefix, name, and IDE is always the second element. The first element, if it has 2 or more atoms, then you'll put a prefix before the name. But if it's just 1 atom, then you just name it. So let's do several examples. All right, here we have phosphorus and oxygen. The first element, you name it, and if there's 2 or more atoms, you'll use a prefix. We see here that we have 2 phosphoruses. So I look up at my prefix, and di stands for 2, so I write diphosphorus. And now my second atom is oxygen, and I have 5 atoms of oxygen, and the prefix for 5 is penta, so I write penta. Instead of writing pentaoxide, I'm just going to write pentoxide. So I kind of just took off the A so that it's not, so now we're having 2 vowels next to each other. So instead of writing pentaoxide, I'm just writing pentoxide. And you see how I added my IDE ending. So in covalent, the second element is going to have a prefix, then your element, then the IDE ending. Let's look at another one. This one has chlorine. We only have 1 chlorine, so we're going to write it like this, chlorine. We don't put the mono ever on the first element. Okay. The second element, we have to put the prefix, and so this prefix is going to be tri because I have 3 fluorines. And then I'm going to write fluorine, but instead of writing fluorine, I have to change it to fluoride because I have to have my IDE ending. So this is chlorine trifluoride. So essentially with covalent compounds, we use the prefixes. It's very, very important when you're looking back at these rules that covalent compounds, so nonmetals, are the only ones that use prefixes. Only for covalent. Ionic never, ever, 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 ever use prefixes. In fact, the little subscripts don't matter in ionic at all, except if you're doing a transition metal and you're trying to find its charge. So in ionic, we have to follow these rules. In covalent, we have to follow these rules. So it's really important that we memorize these rules. And every time you see a compound, right before you're going to name it, you got to ask, is it ionic, is it covalent, and then walk through the rules, okay? That is it for your last video. Sorry, I get really emotional at the end of the year and it's the last video. You guys are going to go like a month without seeing me via digital video files, and I know you're going to maybe feel like withdrawals are going to happen, but let me just tell you that the first video of the next year is going to be pretty baller. So get excited for that. And happy holidays!